One, if you're watching this after the fact, make sure and check the comments for time codes about when things are going to get going. There's some housekeeping waiting for folks that happens at the start, so be aware of that. I'm going to try to set the Twitch title because I don't think the Twitch title is... Oh, and I have to pause this. So we're just getting warmed up. Check the description for the actual time when we do that. Turn off the green screen. Anybody know how to set the title on Twitch? Maybe I can't. I don't see it. I tried to do it through Restream and it didn't work. How's this audio level? It looks like it should be okay. Kitty cam. Had to restart. Oh, it's got the... We're doing some drywall here, so you can... This is the top of a stair, so let me move that. Audio's fine, good. Let me say hi to folks. So, hi Mark, hi Bruce, hi Johnny, hi Jim, hi Sean. Directly on the Twitch page. See, can I do it? No, see, I don't actually have access to the Adafruit account, although I am a mod now, which is good. Hi Randall, hi Hams Labs, hi Toddbot, hi Omsai, Mark Gambler, Luz Theron Telemon, and Keith EE. Johnny's spoiling it a little bit. Maybe if I do it directly, it'll work again. So if folks have questions, go ahead and do that. I'll do housekeeping in just a smidge here. Hi, Gary. Looks like Restream's working as well. Let me just try update titles again. Maybe I can do it when it's... No, it says connect an account. Weird. Looks like it worked for... Oh, you know, it has an @ symbol in it. Maybe that's what it is. No, it's had that before. Yep, it's another ski weekend. I'm having a 3-day weekend. We're renting a cabin out near the ski slopes, so it's gonna be really nice to get away and be within like 20-minute drive from the ski slope instead of 2 hours, which is gonna be awesome. All right, I don't know. I'll just be John Park. Although that retro reflective stuff is really cool. Status title. Yeah? Nope. All right, well, the Twitch... For those of you on Twitch, the title's wrong. Unfortunately, I don't have a nice green screen. All right, let's get going. I got some mailbag to show off actually that I didn't realize I was gonna have, but so we'll do that in a little bit. But I think we've got some folks. I know we're on a weird day. We're on our backup day. But let me just take a time code and kick it off here. So hello everybody, my name is Scott. I work for Adafruit on CircuitPython. I go by Tan Newt online, so if you see me there, that's what you'll see me as. Let let's see. Adafruit is an open source hardware and software company based out of New York. I'm based in Seattle, so that's why my times tend to be in Pacific time. And if you want to support me or them, please go to adafruit.com and purchase some hardware. I know that Feather RP2040s were a hot ticket yesterday, so that's exciting. So thank you all for purchasing those. I didn't know what the price was. I saw that they were $12 and I was like, wow, that's a really good price for a really good Feather. So it's going to be good when there are more available. And I'm sure, I know we have more chips than what we put in the store, so it shouldn't be like weeks and weeks until we do get more in. CircuitPython, if you don't know, is a very easy to use, easy to get going, easy to iterate on version of programming, Python programming for microcontrollers, which are little tiny boards. And I usually show one off to emphasize how big they are. So here's I got a production version of the Feather RP2040 in nice Adafruit black, which is awesome. And I was very lucky. Earlier in the week when they were manufacturing them, they actually had some flash issues, and so Lamore actually sent them to me. It looks like you need to be an editor to change stream details. Yeah, $12 is nearly ludicrous. Yeah, I mean it's $8 more than a Pico, but there's a lot more going on this Feather than there is. So for those of you who don't know, comparing, let's see, here's a Pico. I know I'm not done with housekeeping, but let's I didn't get the overhead going, so they're pretty similar size, and sorry for the shadow. So the Feather's on top, the Pico's on the bottom. Some things that you have on top that you don't have on the bottom is a LiPo charger, so you can plug in a LiPo battery there. There's a STEMMA QT connector there on the end. You have both a boot select button here and a reset button somewhere over here. It's 8 megabytes of flash instead of 2. And that was a last minute change. They were going to be 4, but she had trouble with getting the 4 going. So she was like, oh, we'll just do 8. So that's awesome. And let's see, we have silk screen labels on the top, and the pinout is a standard Feather pinout. So existing Feather wings will work with it. And of course, it has a status RGB LED on there as well. So as you know, those of you who've watched, I've actually had the Rev A prototype of this, the green one. That's been my kind of daily driver in terms of, this is the green one. This is a Rev A. This is the prototype version that I've been using because it's much more convenient. So yeah, so very exciting that these are out. There will be more coming. And let me not get too distracted. Bruce says, I saw some teaser from Olimex where I think they had an HDMI connector. Yay. Awesome. Yes, Sean says I didn't get notice of stock. So sometimes early on, we don't actually do the email because I think actually Lamore told me that like there's actually 2,000 people on the list to be notified, but we only put like 200 in the store. So that's why it's in the works. We didn't want to send out a bunch of emails and not have anywhere near the stock that we need for it. So hopefully going forwards, I think last night they were on during the live stream. So I think maybe next week that's probably a good time to check as well. Sitting in the Discord, if you're in the Discord, sometimes the links will go by when they're in stock. That's another way to tell. But don't be too sad because I do know that we have a lot more chips, which is the thing that we were waiting for. So now it's just a matter of actually picking and placing them. Anyway, okay, so housekeeping. If you want to chat with me and a lot of others, you can go to the Adafruit Discord server at adafru.it/discord. That's the gray box here is the live broadcast chat, and there is a bug in the overlay thing from Discord that makes it not have everything on there, which is a little unfortunate. The white box is YouTube. We're also on Periscope, Twitter, which is Twitter, LinkedIn, and Twitch, but that chat is a chat window that's not broadcast. Okay, deep dives. This is a deep dive. It happens every week. It's normally on Fridays at 2 p.m. Pacific, but occasionally, like today, it's shifted to Thursday. I'm taking tomorrow off. I'm going skiing and actually staying the night at an Airbnb for the Friday, Saturday night, so we won't be here. So taking a long weekend. That's why we're on Thursday. Typically goes for 2 hours or more, probably about 2 hours, about 4 o'clock today, because I don't have that much. Interesting. So John Park was trying to fix the title for me and says that the hashtag RP2040 violates some Twitch naming policy. Is the problem why we were having some trouble there. Lantertronics says, what? Well, wait, so questions are welcome. Next week we'll be on Friday, doing a full week of work next week. And the last housekeeping before I get into questions is the cat is Spook, and he is epileptic, so he does have seizures from time to time. I'll just mute myself and watch him if that happens, but generally he's been doing really well, so I wouldn't expect it. He's just curled up. Okay, that's housekeeping. I know David, DCD, usually does time codes, but Thursdays he's unable to make it. So I'm going to try my best to do time codes here as we answer some questions. So I'll take a time code and answer Lantertronics. So and if somebody else is dropping in there and wants to not conflict with me, just let me know. Asks, what sort of questions / comments should go on Discord versus YouTube chat? Generally, I think Discord's a better place to be. Years ago now, we started the Adafruit Discord because we found that we had these common set of people that would always hop in the chat for the live streams. And the nice thing about Discord is that it doesn't disappear after the live stream is done. So I think the Discord is strictly better than the YouTube chat. If I had to, if I had to say anything about it. Okay, so I do try to monitor both. So if folks have questions. Umsai says, I don't see the reference times you're using. So I have a timestamp here, but if you just do by YouTube time, like that will be close enough if you're doing that. YouTube doesn't show time since start. Oh, I don't know how David does it actually. But what I can do is if I switch to a question, what I'll do is I can drop the time code, and if you can snag the question, that would be really helpful. Or if I change subjects, I'll try to just drop the time in, and then if somebody else summarizes, that's still helpful. Okay, so again, if you have questions, I'm open to answering them. I was actually in the zone working on stuff right before it, which is why I didn't have the YouTube created beforehand. I forgot to do it before JP was streaming, and when JP's streaming, I didn't I don't want to mess with any of the settings because I don't want to kick him off. So let's do Mailbag. So I'll drop a time code in there for Mailbag. So I did show the feather, and my camera's in product showcase mode still. So there's the feather. I got that, but I actually got a goodie bag from Lamore. This is the goodie bag. And you can see I got a second feather. And then because I was doing flash stuff, she actually dumped a bunch of flash chips in here for me. So I don't know if you can see in the bag there. So you can see there's actually some flash chips, and there's actually some RP2040s that she sent me too, which I'm pretty excited about. And those of you who have known, I actually made a GameBoy cart a while back to be able to use CircuitPython to program a GameBoy, and I think these RP2040s are destined, once I respin that PCB, to go there. So I'm pretty excited about it. I just made an offhand comment about oh, like it wouldn't, now that I have a production feather, I can hot air the RP2040 off the old prototype feather. And it was like, actually, well, I don't. Well, she was like, I have chips. I can just send you chips. So she sent me chips too, which is great. Yeah, the Game Boy Cart RP2040, like the original version is done with a SAMD 51, but it had reliability issues, and I suspect that's because the DMA in the SAMD 51 is not super reliable. So the PIO is actually perfect for that because the PIO can buffer and make sure that it's really timing specific. So I'm very hopeful that an RP2040 Game Boy Cart will actually like be solid. So that'll be good. And hi JP, glad you're watching. Thank you for getting the title set up. I appreciate that. My wife just texted me. We're planning what to have for dinner this weekend. So I thumbs up it. Okay, and you can add VGA out to the cart. No, I don't want to do that. So, oh, I guess I should say, if folks didn't notice, you go to the desktop and shrink this down. Boop, boop, boop. I did the Tom's Hardware kind of last minute Pi Cast. So if you just look at Avram's articles, you'll see this article here from Avram. This was actually a result of a discussion I had on the Pi Cast. It's about the work that I want to do, and those of you who watched it know. So here's the Pi Cast recording. You can find it on YouTube as Tom's Hardware as well. But this little write-up he did was about the idea of making CircuitPython run bare metal on a Raspberry Pi. Oh no, Johnny says I was in the zone earlier today, but then the VPN started acting up, couldn't work at all. Yeah, that's a bummer. So the nice thing about working in open source is I don't have to worry about any of that, which has been great. So that's one thing, and then I'll sneak peek. It doesn't officially become public until tomorrow, but Johnny pointed the link to it. If I can snag it out of the Discord. So I was also on this podcast a few weeks ago called Simple Electronics. Thanks to Johnny for the recommendation. And I'll put that in the YouTube. It officially comes out tomorrow. Although it doesn't say unlisted, so maybe it's there. But if you want to listen to a podcast with me and I forget the host's name, but the host is great. Did a really good job. He is a mechanic by training, but still very, very much knows their stuff. So it was really cool, and that's coming. Okay, I actually do have. Let me scroll to the latest again. Hi, David. Thanks for joining. Hi, Yanni. And hi, Mr. Certainly as well. Okay, I have more mailbag. So, my partner, Becca, wanted this thing to go in our house, which is a sensor to go around the house that, I'll put a time code here for you. She wanted a sensor that we could place in different parts of the house to track temperature and humidity and light levels. She's been doing a lot of indoor plants in the house and wanted a sensor. So I came up with this idea. I had seen this case before, but it's a Hammond case. It's a USB case. So in here I have my paper prototype, so to speak. And I guess I could show it versus a feather. So there's the feather. It's like slightly larger than a feather, but it's not that tall. So a feather doesn't work very well in terms of fitting stuff in there. So here's my paper prototype. So I made a board that has a micromod connector on it. So I don't know, it's kind of hard to see, but there's a micromod footprint here. So micromod goes on one side, and then what I did is I decided I still wanted pluggable sensors on top of this. And I've been thinking a lot about how to make low profile pluggable sensors. And the way that I came up with, I was originally going to use this SFP connector. SFP. It's probably on my DigiKey. Let's look at my DigiKey favorites here. I think I favorited it. Small form factor pluggable connector. Yeah. Low profile too. So my frustration with Stemma is that they're pretty large and chunky. Yes, SFP for, so there's these connectors. It's based on this. This is actually not rated for it. It's a generic connector. It's 63 cents a piece, but it's a 20 pin connector, but so it would be reversible. So I was thinking about how to have like just a sensor board, like kind of like Stemma, but smaller and yeah, just smaller. And I was looking at this and it's still pretty big. So in this case, you have like the PCB goes in the middle. So you only have like 6 millimeters above the PCB, and then you have 5 millimeters below minus the thickness of the PCB itself. So there's not a lot of room for stuff in here. So what I actually settled on that I'm experimenting with, and I gave it away a little bit maybe, but I actually settled on doing FPC, which is a flexible printed circuit board. And the advantage of that is, I'm looking through my favorites here. Oh, I didn't favorite any of them. So I bought 4 different versions of it. And so what I got is I actually made some designs from Osh Park. So here's another bag of goodies. I just got this in the mail, so they're very tiny. Papa Romeo Mike asks, why not just use a feather with a 3D printed case? Well, I don't have a 3D printer, is one. And 2, I really like Hammond cases because I previously had a line of sensors that I made that was a 3D printed case, but the battery pack was separate. And it had some wires. And so one of the constraints I had was like no wires. So I really like this idea of a USB-A because all you do is you plug it into like a USB, like an AC to DC converter. So here's, this is the PCB for an SHTC3 temperature and humidity sensor. It's very basic. And you can see here that it's just like, I'm going to like lose it if I sneeze too much. But it's a 10 pin and then it's just got a decoupling cap because I decided to settle on just 5 volts for everything. Oh, I can link you to the case. Yeah. Apparently it's not in here. I need to favorite more stuff. But I remember what it's a 155.1 USB, I think. Am I right? Yes, I'm right. Yeah, so there's 3 different sizes, a 1, 2, and a 3, and this is actually the exact one that I have here. Yeah, so actually the way that I find it is not on DigiKey. For cases like this, I really just go straight to Hammond. MFG. I think that's what their website is. So you could just go like small enclosures and plastic mini enclosures, and then you can see these miniature USB enclosures. So it's one of those. Hi, Unexpected Maker. Yeah, we're on a different day today. We're looking at Hammond enclosures. I really like these ABS plastic mini enclosures, but they also are not tall enough to really fit a feather. This was like one I originally did, but it also has the challenge of like powering it. So I really like actually just using these. And so you can see the different sizes and it's all the same depth, but I actually just went for the biggest one. Hi, Cable Tie. And Hugo, I don't think I said hi to you actually. And Dexter. Yeah, so I have those, which I'm pretty excited about. I super speeded the board itself, but it got lost in the mail. It like just popped up in Tennessee, so it must have like gotten into a batch that needed to be resorted. So, okay, so that one I did. It's that one's a design for temperature and humidity sensing. I also did a NeoPixel board here. So I think it's 5 NeoPixels. And so that should be able to fit like, hopefully, kind of like that in there. And you'll be able to have like it'll be able to show like a scale for a particular measurement, which will be cool. And then I think I have one more design. But the main cool thing is that it's all flat flex, so it's like super thin. Oh yeah, so this is the last one I did. Oh, come on. And this is a Vemel 7700 or something. Vemel, yeah, I think it's Vemel 7700, which might actually be the temp and humidity sensor. So I got NeoPixels on one, and I got 2 other sensors that will cover the light temperature and humidity that I want to start prototyping with. And then I have some of the kits from SparkFun for doing the microbots. So I'm excited to put those together and see how well that idea pans out. So yeah, that's my mailbag. Anybody have questions, or should we deep dive, get our scuba gear on, and I think usually what I do is I recap everything I'm working on. I think I'm actually just going to dive right into where I'm at, and then that will kind of coincide with explaining what I was doing earlier this week. Oh yeah, and I guess I can look at... All right. Papa Romeo Mike asks, will you be able to isolate the temp sensor from the electronics heat? I'm not too worried about... Yeah, Johnny is saying that similar thing that says, just be aware of temperature sensors and enclosures. They tend to be 2 to 3 degrees higher. Yeah, I don't think we're super worried about accuracy. And one thing I think we will plan on doing is we might drill holes in the enclosure. To have more airflow, especially for humidity. So yeah, I'm not too worried about it. I'm not gonna maybe we might get more heat from the AC to DC converter than like it's an NRF. Like an NRF is not going to produce a lot of heat. I don't think because their power efficiency is so good. Okay, so let's talk about Flash. So let's take a time code. Today's deep dive. So earlier on in the week, ladyada was working on producing these, and as she was doing the tester for it, she realized that the 4 megabyte wasn't working. That was her original plan, was to put a 4 megabyte on it. The prototype I had a 2 megabyte on it, but she couldn't get the 4 megabyte working at all. And then she switched to an 8 megabyte, and the 8 megabyte worked after she realized that turns out in CircuitPython we weren't using the let's just talk about all this. So let me pull up the pico-sdk. I still automatically go there. So the way that and maybe the datasheet's a good way to describe this too. I think the datasheet has a good section on the boot process. So for the RP2040, oh yeah, here we go, boot sequence. So let me try to make this a little bit bigger. All right, that's what we're going to go with. So several components of the RP2040 work together to get to a point where the processors are auto reset and able to run the boot ROM. The boot ROM is software that is built into the chip, performing the processor-controlled part of the boot sequence. We will refer to the steps before the processor is running as the hardware-controlled boot sequence. So the hardware-controlled boot sequence is as follows. Power is applied and the run pin is high. The on-chip voltage regulator waits until the supply is stable. And then the oscillators started, the reset controller are all taking out a reset, and the processors start to execute the boot ROM. That's all well and good. What does the boot ROM do? So the boot ROM is 16 kilobytes. Core 0 runs everything, and Core 1 just goes automatically into a low power state. This is the thing that provides UF2, and it also has a... Yeah, so that provides the drive, and it's got some built-in ROM stuff. Ooh, look at that. A flowchart. So let's make the flowchart bigger. It's not a deep dive without a flowchart, right? Okay, so both cores enter boot ROM. If you're core 1, you sleep. If the rescue flag is, you clear it and you stop, watchdog, and then you delay for 100 microseconds, and then read the chip select state. So this is why you hold boot ROM down when you start up to stay in the bootloader. So this is the logic that's doing that. It says if it's low, you act as a USB device, you start the crystal, and you start the PLLs and do all the like USBs, like the RP2 boot stuff. If that's not the case, if boot select is not held down, it will be high because it's been pulled up. And that means you configure the SSI, which is the, what does it stand for? Serial something interface. It's the thing that manages talking to the QSpy flash. And it connects it to the outside world in the pads. You load 256 bytes from the flash. You checksum it, so it's actually 252 bytes plus I think 4 bytes of a checksum. And that's to make sure that you're not just loading garbage. If the checksum passes, then you enter the flash second stage, which is what we're about to talk about. Otherwise, if the checksum doesn't pass, but it's only been less than half a second, you just delay and you increment polarity and phase and delay and then try it again. So there are some retries here. And then if that doesn't work after the half second, then you just go into the normal like USB bootloader stuff. So this is what the ROM code is. So this is code that is not going to change. Is anybody else having video issues? It looks like Randall is having audio, no video, all dark. Let's see what folks say. Yep. Mr. Certainly says here, and Papa Romeo say that they're good as well. So yeah, Randall, try refreshing. You probably can't hear me, but I did reply to you on text as well. Awesome. Thank you, folks. It's interesting to see who's fastest. See how thank you, everyone. I didn't want to keep going if that wasn't the case. So, okay, so this diagram doesn't really have doesn't really cover what I want to talk about today, but it's this flash second stage. And let's see if they just have some more information about it. Watchdog boot. Flash second stage. So it says the flash second stage must configure the SSI and the external flash for the best possible execute in place performance. This includes interface width, clock frequency, instruction prefix, and the continuation code for address data only modes. Until the SSI is correctly configured for the attached flash device, it is not possible to access flash via the execute in place address window. It cannot be reconfigured at all without first disabling it. Therefore, the second stage must be copied from flash to SRAM by the boot ROM and executed in SRAM. This is the only job of the second stage. All other chip setup PLL's voltage regulator can be performed by platform initialization code executed over the interface. So that's what we're talking about today. Good. Randall had a refresh, fixed it. So thank you everybody to helping debug stuff. Here's the checksum things. Doesn't really matter. This stuff doesn't matter either. And so basically what the problem is that almost all of the code is stored off the chip, right? It's stored on the separate SPI flash. So the question is like, how do you figure out what flash it is and how do you talk to it? And so this is a common problem. The IMX RT has it as well. Along with the ESP will have this problem as well, because those are all execute in place sorts of systems. And they all, I believe, have this process of like, there's some very basic, very hopefully well-tested boot ROM code burned into the chip itself that does that like first initial bring up. And so you have this process of like figuring out, I guess we talked about this a little bit last week, didn't we? Picking up where we left off. So getting this right means that your code will run. If it doesn't work, like you could get into some very weird state. So what have I done this week? So let me just talk briefly about that before I pick up where I left off. There are... I guess I can show you the second stage. So the way that the pico-sdk handles it is they have this boot stage 2, and then they have, let's see, 1, 2, 3, 4 options in terms of flash initialization. And this generic O3H is actually the one I thought we were using, but it turned out we're not using. And this is why the 8 megabyte didn't work with CircuitPython. She got it working with the pico-sdk for the test, but it didn't work in CircuitPython until I looked at it earlier this week. And so what we did in CircuitPython to make it work before beta 3 is we actually turned everything but the Pico onto this version, which is the generic flash read. So it's a very short bit of assembly code that is disabling the SSI, setting the clock rate, and then setting it all up to be the most basic settings. Beta says 4-byte flash. So the flash is connected over quad SPI usually. So that means that like for every clock you're reading 4 bits back. But yeah, 4 megabyte is what I was talking about too. How big the chip is. So the production version actually has 8 megabyte. So the 4 megabyte flash was having problems. So if you look closely here, there's this command read, and that's what the 03 is. That's the standard command for reading. And it's so standard that that's the command that is used to actually load that 256 bytes off in the first place. And that's common for the IMX RT as well, is that they load a chunk very slowly, hopefully reliably off the flash that includes settings and then reconfigures to have the faster settings. Okay, so we have this problem, and I showed this off last week, of we have flash and configurations in a bunch of places. Oh, you mean 4-byte address. So the RP2040 cannot do execute in place over greater than 16 megabyte versions. So basically 16 megabytes is the limit. And I think that's pretty common in terms of like IMX and ESP as well, I think, but I'm not positive. So what I was talking about doing is doing this toml thing, and I did it. So if you go to adafruit.com/nvm.toml, what you'll find now is that I broke it. It's failing for some reason. But there's MRAM, which is magnetic RAM, which is pretty neat. It's non-volatile RAM. And the reason that we have support for this is it's useful in space. Because the memory doesn't corrupt in the same way or as often in space as regular NOR flash does. So somebody added MRAM support for the satellites that run CircuitPython, which is very cool. But if we go to Flash, now we have this listing. And you can see here, there's this flash.toml that says supports fast read. So everything under this subtree will have this value as well. And then if I just click like gigadevice and I want to use like, this is the 4 megabyte. So we can see the total size is this, the capacity is that, and write status register split is true for this particular version. And if we just go back and look at the 8, I'm actually curious. So write status register is also split and capacity has a different value. So those look pretty similar. And then we also have this gigadevice.toml, which is all the settings that are shared. So like the manufacturer ID is the same. The memory type comes back as the same. The max clock speed is the same, blah, blah, blah. So that is pretty neat. Now, what I really want is I want to be able to say, like, give me all the settings for a particular thing. So let me show my terminal. And I did actually just update this. David G says, are there boards where I can remove the flash and replace by SRAM, just like we add flash to the QT Py or SRAM QT Py? So you wouldn't want to use SRAM because SRAM is volatile. So you wouldn't have any, like, you'd only be able to store your code for the period that like you powered it. But I would look at the settings for the SSI and you probably can. This is the place you would need to change it. MRAM's pretty cool, but it is kind of like $20 a chip or something. But MRAM is cool because there's no erase. You just write directly and you can read immediately, I think, as well. Okay, so I'm just going to source a different virtual environment here, and then I can do pip install cascade toml. So this is the other tool that I did. Yeah, you could use MRAM. But you have to get this stage 2 stuff set up right, which is what we're talking about. So there's another repo here that is GitHub Adafruit Cascade Toml. I just fixed it. There was a bug in this morning. But what I can do now is I can do Cascade Toml. Oh, that's kind of small, isn't it? That's a bit bigger. So it's Cascade Toml filter, and then you say, this is the SKU I want to filter on. You enter, and what it does is it squishes all those together into one kind of resulting toml file. And I like these comments. I'm using this library called TomlKit, which allows you to round trip toml. And we talked about this last week as well, like how nice it is to be able to programmatically like refactor things. So having a library that can take in a file and produce the file identically, again, is really nice. So we can see that this is all the data for this path. Here's the data we inferred from the path itself. So we know it's flash, this is the manufacturer, and this is the SKU. And that's coming out from this parse pattern here for the toml file. And then from the top level, we see that it supports fast read. And from the gigadevice toml, we see that all of these things are the case. And these are things that are uniform across all gigadevice flash that we have in here, at least. And then lastly, we see that these are the things that are from the SKU specific version. So that's really nice. So now what I want to do is I want to take this in and I want to produce stage 2. Basically, I want to, for anything in this database, I put it in quotes because it's like not really a database, but a lot of the operations you do on it kind of are. But it's meant to be both human readable, modifiable, and machine readable and modifiable. And I think this like toml style is kind of the sweet spot for that. So that's the challenge. The challenge is connecting this toml structure. Sorry, I want to move a window you can't see. So connect this toml structure to produce a stage 2 that actually will start up the particular flash that it's doing. Now, I did have a challenge issued to me by ladyada actually, which is what if we came up with a stage 2 that could handle all the chips in here, all the variations of it. So that is something I might try. And let me pull up my editor, which I don't even have open yet. I restarted my computer before the stream, so I'm a little out of the zone. Like I don't have everything set up. So here's my editor. And the first thing I wanted to do, actually, what I wanted to try is, so here's the assembly. Here's the assembly for doing the very basic, very generic initialization. And there's a couple things here, is that there is actually this include, which is including assembly inside of it, which is kind of weird. And then the assembly that's included is this chunk. And if I look again, there's also a more complicated version, which is this, like, the one that's used most often, I think, is this one, because this is the chip that I think is on the Pico. So this is kind of the one that is it's most complicated, but it's also the one that's actually being used. I haven't looked over it completely. It takes some time to grok what it is. So one thing I decided to do is I wondered whether I could get away with not doing assembly. So it's easier for me to read C code than it is assembly. Like C is the original high level language, right? Like maybe not the original, but like at some point C was a high level language because people were doing assembly before that. And so I kind of wanted to see if I couldn't do the same thing, because I feel like I have a lot of experience with understanding how C gets translated to assembly. And so what I was working on earlier is actually translating. I started with just the basic stage 2, and I decided to make a stage 2.c. Luz says, I'm afraid of the person for whom it isn't easier to read C than assembly. C code than assembly. Yeah, I mean, when you're doing that though, you have caveats. So one of the caveats to think about is this has to be less than 252 bytes of code. It also has to be position independent, because it's actually used in more than just the stage 2. So stage 2, it gets loaded in at a particular address, I believe, that they do tell you. But that code is actually also used when doing any sort of other interactions with the flash, because if you want to do like a read the unique ID or erase or write, basically what you do is you turn all of the execute in place stuff off, and then you do whatever you need to do, and then you run this code again to get it back into execute in place mode. I used something called TAL, which is like C but lower level. Yeah, so there is some trickiness there. So there's some challenges with this. So what I was doing earlier is I wasn't looking at this one. This is the complicated one, and we'll take a look at this maybe and try to pick it apart. But I did manage to get a stage 2.c. So here's the equivalent of this. So here's this boot generic thing, and I don't have enough window to actually show you each one. But so this is setting a register off. It's setting the baud rate. It's configuring something. I can't even, like, I figured out what this is. Quarky says Matt Godbolt probably likes to read assembly over C. No way he could have written Compiler Explorer otherwise. Well, I mean, Compiler Explorer is built upon the disassembler. So what I was doing is I have this stage 2 boot that I made. There is a bit of assembly in here. So what this is doing is it's taking the LR, which is the link return. And that's what LR is, right? Basically, this is where you jump back to executing when a function finishes. So we save that. We disable the SSI. We set the divisor, like the baud rate. We set this first control register, which includes the command and the number of address bits. And then we also set it to do a single 32-bit read, and then we re-enable. Now, so this is the equivalent here of, let's see, from here to here in the assembly. So one thing I like is that, like, whereas assembly, you have to worry about like loading the value into the register and then setting another register based on that register. So there's like a little bit of indirection. There's a little bit of indirection that makes it harder to read, which in C code you don't have. You just have the assignment operator. And then, so what this is this chunk here is the included bits, which I think I have open. Exit from boot2.s. So this is the pop the R0 off the stack. If it's 0, then we vector into flash. So this is how this code can tell whether it came from the boot ROM or not. So if it came from the boot ROM, then we vector into flash and we do this stuff. Otherwise, we return. So that's what this is. BX R0 is jumping to where we run, where the code like resumes from when you return. Vector into flash, what it's doing is, and I don't think this is very easy to read. I had to look up this one in particular. So let me show it from the C side first. So it does still use assembly, but basically the position of the binary is that you have 256 bytes at the start, which is this number here. This hex number here is 256. So from the start of the flash, your actual ARM kind of image starts 256 bytes in. So this is, and what the thing at that position is called the vector table, which is like a standard layout of information that the ARM CPU uses. In this case, it's a Cortex M0, so that's what we're talking about. But the vector table includes the stack pointer, the starting stack pointer, and then all of the different handlers. So reset handler, fault handler, and then at some point it switches into like all your interrupt handlers. So when you make an interrupt, the pointer value of that interrupt goes into this vector table, which is used when an interrupt happens to figure out where to jump in the code to handle it. So vector table, and then there's this, the CPU itself has this VTOR register, which is the base address of the vector table. So when the CPU starts up, it's 0. So the boot ROM must be at 0. I think that's true. I'm sure it's configurable, but basically it's originally VTOR is set to where the boot ROM is. And then when we're handing off to other code, we switch where it is. And so this is us shifting it to the address of the vector table. So we take this pointer and we cast it to just a regular number. And then what we do is the first entry in the table. Oh, this isn't right. I think this is a 1. So it's a table of 32-bit integers. The first one is the stack pointer. So this is the assembly to set the MSP, which is the main stack pointer, I think, to that value. And then next what we do is we do BX, which is a branch, and it's an unconditional branch, so it's a jump. And we jump to the second entry in the vector table, which is the reset handler. So I think this is right. So the next thing we're going to do is test this to see if the code that we build with this actually still works. But let's just go over this. So what is this? Why is the assembly doing this here? So here's our comparison. Here's our return if we're not doing the special case coming from the boot ROM. We get the vector table offset. We store, this is storing the address of the vector table register. This is a store instruction that's storing the vector table offset value into the address to the address of the VTOR register. And then there's this, which is a load something increment after, something like that. So basically it's doing two things. I think it's doing two things. So it's loading the stack pointer. Yeah, that's what it should be doing, is it's loading the stack pointer from R0 into, or no. Yeah, so it's loading the stack pointer and it's loading the reset handler address. And then this is the thing that set the stack pointer, and this is the thing to jump to R1. And there is like an increment that's happening here as well. So like you'll see, like, yeah, there's an increment in there somewhere. I think I have it right. I think I've deduced what this code is doing. And maybe somebody can describe that better than I can, but I was like, this doesn't seem right to me. And then I realized, I looked up this instruction and it was like, oh, it's doing an increment. So like that would mean that like this R0 gets shifted by 4, I think. All in one go. So I think the stage 2 is right, but I haven't, I had to take a call and come back to assembly. Yes. So the good news, Mark, is that I think I've successfully converted this assembly to C. So here's the equivalent C. I mean, it's mostly C. There is some assembly in there as well, but it does compile. So I just want to test this and see if it works. So let's go here and we'll do make and clean. Johnny says it's load multiple increment after. LDMIA. Drum roll. Well, I know it compiles. I compiled it earlier. But I'll just take one of these feathers. Let me put one away so I know which one I'm working with. Let's just use it with a brand new feather, shall we? Oh, so I never talked about... So the reason... We had this point where Lamore was loading an CircuitPython on the 8 megabyte chip version, and it wasn't working for her. Now, I didn't have a bare 8 megabyte chip here, so what I did is she's like, oh, check these boards have the same chip. So I found a prototype Pi Gamer Advance, and it had an 8 megabyte. So I hot aired it off there, and I put it on my Feather prototype, and it worked. And she was like, wow, like this doesn't make any sense. And the reason is that this flash chip had been initialized. There is this bit in the status register of flashes, usually, that say whether it should be a quad flash or not. And so she wasn't working because the initialization code for the quad enable bit was not working on the new chips. But if you use a chip that already had it enabled, it worked okay. So yeah. Yeah, the owl's name is Minerva. But yeah, Minerva should be our mascot for assembly stuff. Okay, so I'm going to plug it in, and I'm going to hold boot down. Sorry I don't have the overhead going, but take my word for it. So we should see... Oh, good. We got an hour. I can get some stuff done here. We should see it pop up. Maybe I didn't hold on to it long enough. There is that delay, isn't there? This CircuitPy drive here is the drive for the timecode thing. So I'm just going to hold boot select again and hit reset. I think this cable should work. Really? Nothing. This is a new board. Maybe it should work. Like that's a nice thing about a boot ROM is that. There we go. Huh. I don't know why it didn't work that first time. Okay. So ports, Raspberry Pi. I don't know why I've gotten 2 tabs open here. Raspberry Pi build feather RP2040 and firmware copy over. And it should work because this is the generic version, so it should work with the 8 megabyte version just fine, and we should get a second CircuitPython drive if my stage 2 is working. But it's not popping up, so maybe it's not working. It looks right to me. Bummer. Well, what do I do now? I/O error. That doesn't look very happy. This is the... Let's just plug it back in. Did it do anything? David says, will the next revision have less slash? No, I don't think so. It'll always be 8 just because I had to get it out the door with 8. Printfs. How do you debug something when like nothing else is going yet? The harder version of printf is actually like we could add blinks into it. Yeah, Hugo says you can always make things blink. It's true. I cleaned it built, and it didn't look like it came up at all. Huh. So one thing I was doing is I was looking at the SWD. Yeah, I could do SWD as well. I don't have it on this board, but I can move back to this other one. The SWD is kind of like not super convenient right now because I like using JLink, and JLink doesn't have Wemo says as long as it's not smoke signals. Yeah, that's pretty safe bet that it's not smoke signals. Oh, the other thing I was doing is I was looking at the assembly that was resulting from everything. So this is what we're doing right now. We're getting, so this is the assembly output we're ending up with. And I looked at it earlier and it looked right to me. But this is also of the elf. Hi, Jose. Ibrahim says SWD. Let's make sure that, I just want to make sure that everything is working as expected. So let's just make sure that the padded and checksummed version looks reasonable. Oh, yeah. I think I could just open it here. Raspberry Pi build. So what happens is that it gets compiled into an ELF, which converted into a bin, which then it gets converted into this file. Which is then checksum. So the last 4 bytes here are the checksum. And we can just compare here. So this is our debug. So 4671. So we are right at the start there. The one worry is if we happen to have, and then I basically want to just check the start and the end. So here's the 00, the 100104, and then the E. Gareth says, where is the LDMIA? I don't think I need it. So I'm doing it differently. Yeah, we're doing it differently. Yeah, so I don't think we need the LDMIA. And it looks like I just got pinged by ladyada, so she wants to stop by again. So we're going to get interrupted by ladyada here again. She'll save us from our assembly. So I think this is right. I think this padded and checksum thing is right. And then we can actually check the UF2. So there's Octeta. I'll turn my audio on here. CircuitPython ports, Raspberry Pi, firmware UF2. And then if we look in the UF2, there's going to be some metadata in front of it, but then this looks like the checksum here that we saw, the BF79. So that looks all okay. Hello.
Hey.
Let me pop you out. There we go. We're deep in the weeds, let me tell you.
Oh yeah, so maybe now's a good time for like intermission. Woo!
No, I was like, I just said you're gonna save me from assembly code.
Oh, cool. That's what I like to hear.
So I'm trying to convert the assembly for the stage 2 stuff to C, so that we don't have to do assembly.
Yeah, sure. I mean, up to you. I saw like some funny tweet. It was like somebody was like, you know, could I have written this code in C instead of assembler? Yes. Would it probably have been faster and smaller? Also, yes.
Yep. Yeah.
You know, don't discount the compilers. Compilers are really good at this shit.
Indeed, yeah. Yeah, but I just tried it and it didn't work, and now I'm like, oh, great.
Oh no. Do you have a disassembler?
Yeah, I disassembled it. I mean, it doesn't assemble to the same exact thing, but it looks okay to me, and I just checked that it's also in the it gets into the UF2 like I would expect as well. So I'm not exactly sure.
Okay.
But we'll figure it out.
It's an endeavor. You know, I'm actually thinking, you know, and I don't have, I mean, people who watch the Desk of ladyada know why we're doing this is because we decided not to go with 2 megabytes of flash on the RP2040, and the 2 megabytes of flash happened to work with the same flash chip definition that the Pico had.
Right.
But we wanted more, so we were like, let's get a 4 megabyte flash, and like foolishly, I was like, what could be that different, right? It's like the same flash family. It turns out like it's totally different. And the 4 megabyte we never even got working. I did send you some. I don't know if you tried it.
Yeah, I haven't tried it.
I sent you some 4 meg chips.
I just showed the goodie bag that you sent. But I haven't done that yet.
Yeah, and then we were like, well, that doesn't, and as I was like writing the tester code, so, I was working on the tester last weekend, so I can hold it up, maybe see if this, it's hard to see if you can see, but whatever. So, you've got the teensy brain, well, the teensy's removed because I don't know why, but I think I was using it for something. And then, the tester body, the thing that actually does the testing, and then the clamp that holds it down. And I did this thing where I was like, well, because I just wanted to get these out fast, we don't do what we normally do, which is load a test program that tests all the hardware and the pins and everything, and then separately load CircuitPython after, because it actually just takes a little bit longer. It takes like another 10 seconds. And I was like, well, you know what? Maybe we can just load one program and the program does the test and also does like a NeoPixel swirl. And so folks who don't know it's a test program are like, oh, look, it's like the demo, it's like it's color swirling. Great.
Right.
So that's my little hack. And so I was writing that code over the week on Sunday to get it working on the RP2040. So I was actually learning pico-sdk, which is actually really wonderful. And it was super easy to get going. So I do recommend checking that out. But their default flash chip was, again, the one on the Pico, which is not generic. It's the WinBond W25Q something. So, what's funny is I was like, the format didn't work, and I was actually not sure why. And I was like, ooh, like scary. Didn't even like boot.
Mm-hmm. Right.
So I just like swapped out because the Feather, we have so much space, and what's funny is when I first showed this to Eben, he's like, why are you using such a large flash chip? And I'm like, if you use if you put down a big package, you're free to be flexible, right? It's not going to focus, but we can look at the product page. But it's wide or non-wide SOIC.
Yep. Yeah, I noticed that because I put in the 8 I put on was wide as well. And I was like, oh, perfect.
It fits both. Ask me how I figured out not to just use the narrow one, right? Like you make that mistake once and you're like, you use wide from then on, right? If you can fit it.
Right.
Put it on. And so I swapped out the 8 megabyte flash that we actually use for like the Matrix portal and the Pi portal. We use it a lot, so I know it's a good flash chip.
Right.
And that one also didn't come up. And then I was like, okay. And then I was thinking about, you told me like a long time ago, like, don't forget, like, it's kind of like that scene from like, Star Wars where it's like, use the Force, Luke. But instead it was like you floating in space and saying, don't forget the flash initialization assembler. And I was like, oh, that's right. I went in, I swapped it for the generic, and it came up. And so, but the 4 megabyte still didn't. So the 4 megabyte isn't even generic, like it wasn't even working with the generic definition.
Yeah, which is very weird.
I don't like that. So, so that's why I wanted to go with 8. Basically, like I had to make a decision. I think long term, I mean, Scott, you're going to hate this, but I think long term, we're probably going to go back to WinBond. So some feathers will have GDs and some will have WinBonds. Because the more they think about it, if I can get WinBond, I think long term I'll be able to get WinBonds for the same price. Like right now, I just have the stock, and I wanted to get people these boards. I actually think people. I had this feeling that the Pi folks are not going to be super conducive to changing the Pico SDK default to generic.
Mm-hmm.
I don't know. So I'm concerned that there's going to be a lot of people who get their boards and then they load the Pico SDK example, or like somebody distributes a UF2 and they're like, it doesn't load, your hardware's broken, right? Which is like, it's just a lot of tech support. And that's why I like having this like tester also, because I can be like, look, load this UF2. Right. Does it work? Great. Then it's not me.
Right.
So long term, I think I'm gonna have to go to WinBond, just because I think in the long term, yeah, and it's not a technical decision; it's just totally an emotional decision, right? Which is like half my decisions are emotional. It's just an emotional thing of like, I just know that other people are going to be compiling Pico SDK projects, and they're going to use the WinBond definition, not the generic definition, distributing the UF2s, and then folks are going to say stuff like, oh, the Adafruit Feather doesn't work, it's broken. Right. When it's not, it's just, it doesn't use that same WinBond flash definition.
Mm-hmm.
So I think I'm going to continue selling the ones we have now, whatever, what's the name of it again? Giga device?
Right.
Call them GDs. The Giga devices. And we'll have CircuitPython for it, but I think I will start sourcing WinBond, and hopefully if it's within a couple cents, I'm just going to swap over to WinBond chips.
Right. So background for folks is we actually did the reverse of this a few years ago with the Circuit Playground Express, I think it was for. And it's what really...
Right, we started with WinBond. Yeah.
Yeah, it's what led us to the system that we have today in CircuitPython that's used for most of the the external SPI flash chips that we have, where when we start up, we actually read some of the JDAC IDs, like the manufacturer and the capacity and things like that, and then we decide based on that what to do. So it's not unheard of to have to do this.
Yeah.
So yeah, that's kind of where it came from, and now what I'm trying to do is I'm trying to factor it out even further.
Yeah, so now, can you still hear me? Just because I'm now screen sharing.
Yeah, I just
okay,
gotta change my window so folks can see your little.
do you want me to change the window size or
No, you're good.
Okay.
I scooched you over so folks can see your thumbnail in addition to your screen.
Yeah. Oh, hi. Oh, that's cool. It shows both. I know that. I don't know nearly as good as this board. So having, done this and, and then I had another realization, there's it's like, you never know what you don't know until you realize you don't know it.
Oh yeah.
So I was like, okay, well, look, we're gonna have to go to 4 or 8 megabytes for the ITZY and the QT Py as well. Mm-hmm. So then I was like, okay, let's go source those chips. And then I realized that those chips aren't available in the 2x3 USON. And I don't know why I thought they were. The max for the USON is 2 megabytes. And again, we don't want 2 megabytes. We want 4 or 8. And so when I researched it, basically you have to go from USON up to XSON or WSON. I don't know. It doesn't matter. It's 4x4 and not 2x3 millimeters. So the chip has changed size. So if you look at this has, this fairly large flash chip here. Maybe I'll turn off the back layer so there's less going on. So this is I'll turn on the T-Docu. I like T-Docu, but it's always hard to find the drop down. There you go. So you have the 2 buttons here. So I kind of shifted the buttons over, and then the flash kind of just sort of slid in between right over here. So the flash, this is a 4x4 flash, and there's also 4x3 flash, but I'm like 99% sure it's just narrower. So like 4x3 or 4x4 would fit. And again, same thing as the wide or narrow SOIC. Pick, fit the widest thing you can.
Right.
SOIC definitely would not fit. This is half the size of the SOIC. But I, revised the ITZY, and basically I moved everything to 0402 that was basically a resistor or a very small capacitor. Mm-hmm. A lot of these parts were 0603. I shrunk them down to 0402 and then shoved everything over. You can barely tell, but this moved over 50 mil or something.
Right. And you had to redo all the traces as a result?
I had to redo but only the right hand. The left hand side, you can even see this is a little spaced out, right? This is not, it's not as tightly bound up as it could be. A few things too. Like you saw, there was a via here that I removed because I ended up having to I changed a little bit of routing. Mm-hmm. The IO pins do not match the ITZY pins at all anymore, not even close, but that's okay. But I got to fit this large flash chip, and I did the same thing for the QT Py. I swapped it over from a USON to a WSON or XSON.
Right.
So I can fit 4 or 8 megabytes comfortably.
Right.
I don't know why I thought they was available in. Same thing. I always get bit by these
the 2x3s?
Flash memory things.
Yeah.
No, just like flash memory, man. It's always just I don't know, just a problem. But I'm going to do a revision anyway. I'm going to send out panels today.
Okay.
I also have to do the tester.
Right.
So I can also show.
Do you have an idea? Somebody's asking which flash chip will be on the ITZY. Is this going to be a last minute call?
It's probably going to be the 8 meg. I'm probably just going to settle on the 8 because I think the pricing was not that different. Mm-hmm. The pricing jumps at 16, but I think 2 to 4 to 8, it's less than linear. Mm-hmm. And the cost of the RP2040 is low enough that I feel like we can kind of bump it up. It's also just one of those things. It's like, I feel like we're going to only stick more stuff in the firmware.
Yep.
Especially especially for folks who are going to turn these into computers or keyboards or I don't know. I think that given that it has a little bit of extra power and it uses the flash on chip.
Right.
I don't know why not. So I can't, because I'm getting special pricing. I can't see what the pricing is, but hopefully the pricing I can get for the Win bonds are good enough to justify it. So that's the ITZY, and then the QT Py, same deal. I can open that up and show that off.
That's exciting.
Real fast. So that's what I did today was like, look, and this is actually, you know, it's interesting. This is why I don't release multiple boards of the same family at once. Because there's always stuff like this that happens. And you don't know what you don't know.
Right. So you do the feather first and you figure out the kinks.
I do the feather first.
Then you do the other two.
Like this like, by the way, I totally like bought 1,000 of these 4 megabyte flash chips sight unseen because I was totally like, what could possibly go wrong? It's like everything could go wrong.
Yeah. Gareth says,
life is meaningless.
Gareth says, I think this accidental bump in capacity will turn out to be a really good thing.
Yeah, no, I think it's good. And also I think like, you know, Pimeroni put 8 megabytes on their like little teeny board. And I think so everyone's sort of going that direction.
Right.
Which is funny because the original dev kit for the RP2040 was 16 megabytes, remember? Like you and I got one of those like initial dev kits.
No,
and then
I got a Pico. You got the dev kit. I always got a Pico.
I got a dev kit. So the dev kit actually did have a 16 megabyte because I think they were like, well, we have to test it with the max.
Right.
But I think 8. And it's a good look. We did it from the Pi portal and the Matrix portal and a couple of basically anything where you do like AV stuff, because basically once you have audio files and like images, it's basically images that just like totally hog up the space so fast. Fonts and images take up text space. Although we moved to PCF, so this is the new. I'll show the back because the back is kind of the most interesting thing. So you've got the. Let's turn on the.
So Steven is asking, what is the price of the RP2040 chips themselves? And I think the answer is...
Can't talk about it.
We can't talk about it. You're going to have to wait till they announce that. Yeah.
Yeah. You know what? Here's the thing. I didn't even sign an NDA. I just like, it's just not...
Yep.
Never ask a lady her age, her weight, or how much she spends on RP2040 chips.
I mean, it's important to note that, though. Like, I heard about the RP2040 a month early as well, as a lot of people did, and it was all under FriendEA and it didn't leak, so it works.
It's look, I will. Here's the thing: if the Pi Foundation want people to know, they would tell you, right? Yep. So, it's very competitive, though, right? I feel comfortable saying that because they've said that it's going to be a very, very competitive price. People who are smart can reverse engineer. What I usually say is the cost of goods for products versus the feather price versus other folks RP2040 boards, and you can give yourself an upper lower bound, right? So maybe it's a good Python project experiment, right? Look it up versus.
I was gonna say I was shocked that the feather is $12. Like, that's one of the cheapest feathers, I think, right? Like, that's really good price.
It is. Yeah, it is. It is a very good price because the price for the RP2040 is very competitive.
Hint, hint.
So this is the hint. So this is the 2040 chip crystal area over here. A bunch of capacitors. Again, I moved a lot of parts to 0402. I'd like to keep my capacitors at 603, but I did. Yeah. I made a deal with myself. The 10 microfarads are 805. The 1 microfarads are 0603, and then the 0.1s are 0402. Now in the Pico, they actually use. Now I don't judge people for their manufacturing ideas, but like JFC, they used 0201s here. I mean, was that really necessary? Like, they have space, Why do that? You can look on the Pico, but it's like, why did they do that? So I really don't like going. I don't even like 0402s that much,
right?
Because you need special feeders for them. Oh, can you pop me back to the screen? You need special feeders because they're double pitched. Is it not? Because it's I don't have the screen in front.
Yeah, I don't know.
Oh,
it clicked it back, but
okay.
It's fine.
Discord was being smart. It's like you don't have the screen open, so. So you got 402 caps over here, and you don't see my.
So I can see your cursor. It might be hard to see, but yeah, I want to. Yeah, so I was talking about respinning my GameBoy cart. So this is you talking about what pieces I need to put along with the RP2040 on this cart.
Don't pick Yusan. You have plenty of space.
I do. Yeah.
So I see.
Yeah.
The 0402s are only because again, I really need to squish it down and on the double side. So then I got rid of the lozenges. So there were these little power lozenges here. they weren't that useful, honestly, because they're broken out. This is Bill Binko's jumper. This is a jumper that connects the V bus, the USB power bus, to the 5-volt. So it removes the diode connection protection, but it means that you can back power USB. So if you want to use this as a USB host, you could do so.
Oh, I see.
So it's a little thingy-thingamabobber. Right. And then here is this little fellow over here. This is the bad idea diode.
Okay.
So this diode is the bad idea, Scott, that I was talking about. So, Pimeroni on their board made it so the USB boot chip, the USB boot pin could be used as a button. So I did that. It's a bad idea, but we're not. So the USB boot line, right? This is this on the switch. This is the switch here. Pulls low, and that actually also goes into an input here, and it's diode protected here. So the CS line does not. I think I got it right. The CS line cannot pull it low. Only the button can pull it low. So then with an internal pull up, if I'm correct, I don't know. This pin should be an input, which is I think like GPIO like 23 or something, or 24. I also another thing I did on the Cutie Pie, you'll like this. Yeah, you'll think you hate it, but I know what what are you gonna do?
Electronics are hard.
Well, I can always remove it, right?
Yeah.
So I also I had a little bit with the space I had, but from changing over to a 402, so I moved the RX pin so it's in line with the SPI pins.
Nice. So you have 4 continuous pins.
So these 4 are contiguous.
Right.
Yeah, USB boot is 21. The TX pin is not. That's like the
USB
one pin
boot
that's
is
unfortunately
21?
kind of. No, that's the dumb idea I had.
Oh, that's how you read it. Okay, yeah.
That's my bad idea. Not a dumb idea. I shouldn't say that. It's a bad idea, but whatever. I like. You know what? I'm actually into bad ideas. I think we should have more bad ideas in electronics.
Right. So you're trying to protect this. I'm trying to figure out what the right circuitry is.
Okay.
Right, because
So here's what I think.
Okay, go ahead.
Well,
Explain
here's the
it
deal.
to me.
So, like, Pimeroni doesn't release schematics, right? Which is their prerogative. So, they mentioned, we had some circuitry for this button, and I was like, oh, okay, like, let me see what it is. And it's obviously like the correct thing to use is an open drain OR gate. Okay. If you have an open drain OR gate, I think I worked out. I was like, ooh, that's like the most elegant way of doing it. Such a thing does not exist. So here's how it works, because this is a bit of a weird hack.
Okay.
So the QSPI CS pin.
Yep.
Is tied directly to the
flash CS. Yep.
The flash, which has a pull up. This has a light pull up 10K,
okay.
just to keep it deactivated when not in use. It's also directly connected to here. So this is a direct connection.
Okay.
So when this switch is open, there's a light pull up on USB boot. Right? But this pin, because this is diode protected, only a low signal affects this output. If this is high, this diode is open. There's no connection.
Right.
So when this is pulled high, that is the button is not pressed. This does not affect the CS line at all. This 1K is floating. This is open. This diode, it's like gone. It's not even there.
Right.
When this is pulled low, because the button is pressed, this node is low. And this node is low.
Right.
So this CS pin is low because this 1K is much smaller than the 10K light pull up. And so that is the USB boot, signal. Because the CS pin is held low while power. So you hold it down, and when you plug it in, it detects it.
Right.
So now the third piece is, okay, well, the CS pin is toggling as well, right? Because that it's being used, right, on a day-to-day basis. So I think I got this right.
On a second-by-second basis.
And I said, millisecond. So the CS pin, if the CS pin is high, it's just the chip select is not enabled, whatever, but it's in use, but it's not pulled high. Remember, it's driven high.
Okay. Yeah.
It's driven high, not pulled high.
Right.
This pin is high, and then this is high, right?
Yeah.
So this is the natural. This is normally would be high. If this is low, then this doesn't exist. So the only thing, because it says this diode would be, it's not there because if doesn't pass current. If this side is low, it doesn't matter what the side is. It doesn't pass current.
Right.
So the only situation that is weird is what if this is high, is driven high, and this button is pressed on a normal, like the code is running.
Right. Which is the case I'm worried about. Yeah.
Which is, by the way, the case normally, right? Like normally this diode isn't even here. It's connected directly. So I actually was like, I was actually like, I should just try it. Like I ran my feather and I actually just pressed the button while it was running and nothing happens. Okay. Because this 1K is not strong enough to affect the directly driven GPIO pin. If you think about it right now, if you have a Pico, there's nothing stopping people from just pressing that USB boot button.
Right. But it
doesn't crash.
But the feather has that 1K resistor in there?
They all do. This is part of the minimal schematic requirement.
Ah, I see.
Yeah.
Does it change with drive strength?
It does, but they must be driving it strong enough that it can overcome this 1K. Which is not that much, right? Like 1K is only 3 milliamps. 3 volts through 1K is 3 milliamps. Right. So it just needs a drive strength of 3 milliamps or higher to be able to drive this.
Right.
And basically sync the current through, and then it ignores whatever's over here. It doesn't overpower it.
Right.
Anyways, I think that, look, I don't know, man. I think, right?
It sounds right. I mean, you're much more the EE than I am, but.
It's just to think about like nodes, but I think this should be, the diode basically is what keeps the GPIO pin, right, which is connected here, from affecting CS in any way, or the CS pin from affecting the GPIO pin. Like it kind of separates them in a sense, because this 1K, the only thing that's weird about this is there's this very light pull up, but the light pull up the light pull up isn't overpowered because when this is low, this diode doesn't exist. And when this is high, it's just helping the pull up be even stronger in a sense. So I believe my analysis is correct. But I will say I got a C in 6011, so I don't know,
I mean, you'll try it, and worst case we rev it or something, right? Like,
well, I just delete this diode. Like this normally the diode
you just don't place it
as a line.
Right.
No, it's placed, but it's a jumper.
Okay.
It would be just a jumper. Which I would, in my final review, I would actually just delete it, or I could place a 22 ohm resistor here or something, right? To jumper it.
Bill is asking, will that impact how fast the CS pin rises and falls? Doesn't matter.
No, it doesn't matter because again,
it's directly driven.
The drive strength, they must be turning it on strong enough to overcome this. This 1K resistor is part of the okay. Well, here's another thing. All right, let's actually be totally honest here. So the CS pin doesn't toggle that much, right? Like this isn't the Q-Spy clock.
Correct.
The CS line is pretty much like I could
which is why we bit bang it usually.
Yes, it's usually bit bang, but even the Q-Spy driver, I have a strong feeling that they pull it down and then they keep it down. They probably don't even
You don't need to change it.
Why should you? You don't have to. Once you're in Q-Spy mode, we looked at the Sele traces while we were debugging, and I saw it happen. It happened twice. It doesn't toggle very often.
Right.
Because you don't have to. You're not sharing the bus with another port. The Q-Spy bus is completely dedicated. The chip select is only there to kind of wake up the chip from the initial. When you want to start it up, if it's in a weird state on boot, the chip select kind of tells it okay, this is your first instruction. But once you start giving it the instructions, you don't have to keep doing the chip select line. It's optional.
Yeah,
on a non-shared bus.
Right. Yeah, Bill, you're right. It's exclusive to that bus as well. It does look. I was reading the datasheet for the SSI, which is the peripheral that does it, and it looks like the peripheral itself does have the ability to have multiple slave selects or chip selects on it. But the way that they've configured it and hooked it up, they only have only have one.
Yeah, I mean, that's not, if you look at how the Espressif, they have external QSPI flash and external QSPI PSRAM.
Right.
And, both of those are on the same QSPI bus with separate selects.
Yep.
So I remember they're shared.
Right.
Because I was looking at we're over and they expose the chip select pin and then they say do not connect anything to this pin.
Right.
So I just leave it blank. Whether or not I'm using the PSRAM, you want to leave it disconnected.
Right.
So I think this little hack will let you use the button. So then,
awesome.
So the question is that should I re-add this to the? It's too late for the feather. I think I may rev the feather, and if I do, I'll probably add this little diode because there's definitely space.
Right.
But I want to wait to get more feedback in case there's other things I have to fix.
Yep, that makes sense.
Which there may be, but I can add it to the ITZY maybe. I'm going to try to see if I can make some space for it. Problem is diodes are kind of big.
Yeah.
Annoying.
Yeah, the SOD 123s or whatever.
Yeah, even the 123s are they're kind of chunky. So that's it. So that's my hopefully I distracted you.
That's deep dive with more. Deep dive with ladyada.
Oh my god, there's only 30 minutes, so it's quite a while. But that's okay. 30 minutes is a good.
We got plenty of time. It's all
good
good.
Distraction. Okay.
I don't know how I'm going to debug this anyway. So.
Okay, cool. Well, maybe I helped flush your brain a little bit. But
I mean, I'm almost on weekend too, so I'll just tackle it next week in the worst case. But I might poke at it some more. Do you have any idea? I know folks are excited for the feathers. Do you have any idea when the next batch will be in the store?
We're going to fab the next batch on Friday, I think. All things being good.
Yep.
Which will be a couple hundred. We're still working on the yield.
Okay.
It is an 04. It is a not a 402. It's a 0.4 millimeter pitch QFN.
Ooh.
And there was a bit of bridging.
Okay.
So the first batch had 20% failure. You can rework them, but the rework takes time. We really prefer not to. It would be wonderful if they just popped right out of the oven.
Right.
Pristine jewels of feather. So the next run, we're going to try to we're doing another smaller run of a couple hundred. We didn't notify folks, but when we put the next batch in, I'll try to drop in by Discord and do a little, whoever's in the CircuitPython, I'll be like, hey.
Okay.
Here's feathers, you can sign up. And then we're going to get parts to make, many thousands, but I do want to work out the yield issues first.
Right. So what do you think?
There's no lack of chips or PCBs. It's just a matter of process.
So what are you going to experiment with to reduce the bridging?
Good question. So the first thing I did is when I got the stencil, I got a gold plate stencil.
I didn't know they had those.
Yeah, it's very light. It's like a 1 atom thick, right? And the nanoplate gold helps with the release to get more perfect little ovals of paste.
Okay.
The second thing we're going to do is we're going to try to use cold paste. Cold paste is a little less runny. That might help with the bridging. We're already using gold, NA gold on the pads. If that doesn't work, I might actually go back to the Pi Foundation and be like, "Yo, what do you guys suggest?
What's your secret?
Do you have any? Yeah, do you have any secrets?" I know that they don't do the manufacturing, but
they're pretty involved in it, though. I think.
I know. I sort of wish they'd done 0.5 millimeter pitch, but
I feel
the world I live in. I know. Yeah, it's 0.4 is a little frustrating. But we'll do it. I mean, we handle 0.4 millimeter. And the fact of the matter is I don't have a choice in the matter here. Right. So I'll figure it out. So.
Yeah. And I think that's the argument for actually going to BGA when the pitch is wider is people are like,
when a wide pitch BGA, like a 0.8 millimeter pitch is that's amazing. Huge. So.
Right.
Okay.
Awesome. Well, that's super exciting. I think people are going to be very excited to get that.
Okay.
Thanks for stopping by and
of course.
Diving deep on the schematic side of things.
Yes.
We'll get this. I still have the challenge of making a stage 2 that works for a lot of different flashes. So
yeah,
we'll see what we can fit in the area in that space.
Yeah, now we might have to do one that's GigaDevice / WinBond at the same time. But
yeah, I'll have to take a look.
I think you can fit it.
I have to take a look at what the differences between those two are. But yeah, it'll be good.
Wait, we'll write some Tomahawk. Okay.
We'll be ready for all those RP2040 boards that are coming.
I know. Well, I'm going to send out these protos today, get the testers done, and then we'll see more boards come out. But I'm glad that I learned things. Always learning. All right, thanks
Totally.
everybody, and thanks for having me. Don't forget, we'll have a desk ladyada on Sunday. Which will probably be more of the same. Never end.
It's very exciting.
Okay,
Thanks
bye.
for dropping by. You're still on more. She can't hear me. I hung up on her. Awesome. Well, that was a treat. It's always good to see how everything is going. Obviously, like I'm more of a software person. It's 3:45 and my code still didn't come up. It looks just fine to me. David says I don't understand everything, but I like it. Awesome. Okay. Let me add another timecode for myself. I can add timecodes after the fact as well. Google Foob says, thanks for this cool info. Yeah. If it's cheap, I'll buy a DIY rework kit. I don't think we would ever actually sell that. I saw the example or the suggestion in the Discord as well. I don't think we'd ever do that. I don't think we'd ever sell boards that needed rework because you never know how much rework they need. Because like if it has a bridge, you can't test it, right? So like it's completely untested, and to rework stuff, it takes like soldering, and it takes soldering skills usually. Like it's not always an easy thing to do. So I know that they have people at Adafruit that will rework things. So they'll just get the yield up, and it'll be all good. Bill says, a bit scared by that build issue. We have custom designs that we use the RP2040, probably stick to the QT Pi or other castellated pads for a while. Yeah, well, that's the nice thing about open source is that hopefully, yeah, they run through the same testing after they rework it. Hopefully once that, like the Pi Foundation is really good about being public with their information as well. So I think if more comes to them and says like, hey, what's the best footprint for this? Like they'll publish that. So it's, I think it's all within the realm of like, it's just early and it'll get sorted out. People generally will figure out how to like get the landing pads right and the stencils right for optimal yield on these chips. Like if you're assembling it by hand, I'm not too worried about it actually, because the way that I would do it is I would just hot air the center pad down and then just drag solder. So you just use flux and drag solder, and I suspect it's fine. You don't like bridging is a thing that you get with solder paste and reflow. You can of course bridge it with an iron as well, but I think it's less likely to like not be able to undo it. From what my hand soldering skills. Yeah, I had not heard of gold stencils though. Okay, so what are my options? So this is the first assembly instruction. Wonder what I could do. ATMaker says, Bill says, out of curiosity, was there a benefit to the weird bootloader approach? Not sure what you mean. So all of this, like, if you do execute in place, you have this challenge of like, how do I initialize the flash to be fast? You could leave it. You could always do the generic version in the bootloader and then change it in the user code, but then the user code has to be like very deliberate about like shut everything off, load it in RAM, and do that again. And the nice thing with having the bootloader do that is then it's up to the bootloader to decide like, oh, something's wrong, I'm going to just go into the bootloader. Although obviously that it's possible to have things not work enough that it's possible to have things not work enough that the bootloader doesn't start and it's somewhere in the middle of the flash code too, which is where I'm at, right? Like I'm not getting CircuitPy, but I'm also not getting the RP2 drive. So I'll take another time code, although my time codes may be a smidge. Yeah, I think this runs a bit fast. So where is the ROM code? So the ROM code is open source, which is nice. But in terms of the chip, it's actually like in the chip itself. Trying to think of the best way to show that. I think that if we look, usually the block diagram will have a block for... Yeah. So here's like a block diagram of the chip. And if we look here, we can see that there's this XIP cache, which goes out to the QSPI, but then there's also this chunk of ROM. So it's like the ROM is like built into the chip itself. And it's not always the case that the source code for the boot ROM is made open, but in this case, the Raspberry Pi Foundation did actually publish it. I'm not exactly sure the repo name, but it's somewhere here. If we just do boot. Pico boot ROM. So yeah, if you want to see the source, this is what's on there. It's true ROM, not EEPROM. I believe so. They don't tell you any ways of erasing it, so I think it is. NWK confirms it's a metal layer ROM / permanent. So yeah, it's actually baked into the like way the chip is etched. So you can't change it, which is why you hope and hope and hope that it's correct. Beta says, it's always harder to bridge when you're trying to do it deliberately, such as I2C address jumpers. Saltimba points out you can use solderwick for bridges. Yeah, David says, we don't even have to use X-ray or decap to get the boot ROM. Yeah, and you get the actual source too, rather than a disassembled version. Okay. So this doesn't work. You know what? One thing we could do to debug is, I have it set up here. Let's do this. So debugging flash chips is really handy. So I don't have the overhead here, but my cable's not long enough. So I'll just unplug it before I get it going. So Salier, and I have this, which is a clip, and this is an SOIC8 clip, which is super handy because flash chips are usually SOIC8, especially on the Feather. So what I'm about to do is I'm going to plug this. You can see I have wires to the Salier. I'm going to put this on the flash chip on my Feather, and we can look at what it's doing. So that's, we should be able to see how far we're getting, hopefully. And I can never remember. Yeah, I think ground is on the side of the pin. So I hadn't thought about this is a way to debug with a flash chip, and I hadn't thought of it until now. What is this? Oh, this is the disassembly, or the UF2 logic. NWK says the recent Amp Hour podcast interviewed the RP2040 chip designers, and they explained why they didn't use on-chip flash. It adds steps to the manufacturing process and more money. Wemo says, okay, so this is fun and about as deep of a dive as is possible. Yeah, I agree with you. There was a question to ladyada during Ask an Engineer about like talking about failure and showing failure, and somebody was like, well, Scott's streams always have him failing, so it's good. I think it's one of those things you learn as being over time as an engineer. So I'm happy to show stuff. Hi, Emmett. Debugging by observing. Indeed. Okay. So I think I have this all set up for it. So all I'm going to do is I'm going to hit start. That's the nice thing about this clip too, is that like, I'm just going to hit the reset button. And it recorded. Oh, thank you, Mr. Certainly. Mr. Certainly linked to the test clip. I was suggesting to ladyada that we stock this because it's just, I think they did previously as well, but it's just so handy for capture here. So this is cool, right? This is super handy. What we're talking about. And okay, so we're triggering. Do I not have any of my? No, I don't. Okay, spy. So here's a trick. I never actually cancel. Let's go to. I don't usually actually know, like, look at what pin is connected to what. Usually what I'll do is I'll look at the signal. Oh, that signal does not look good. That does not look complete. Why is that? I wonder if it's not it's possible the clip's not sitting well. So this looks like data, right? Like if this is the first 256 bytes, then this would be our instructions, and then this is the checksum. But like nothing happens after that. So maybe we are failing the checksum. But I just clipped it on, and we're not seeing a clock. There's no clock signal here, which is very weird. I wonder if I put it on backwards, or I just need to. So I'm just putting it on again. And I'm just going to do the same thing. These clips won't sit. Come on. I'm recording too much. Where's my clock line? Like, that's clearly a data line. This is an instruction. Did I pull something out, or? Maybe I don't have it the right way around. I can see pin 1. Check physical first. Yeah. I think I have the. Well, I just unplugged it, so it's not connected now. Do I have the Giga device? Yes. Let me pull this up. Okay, so here's the chip. I clicked. I'm just gonna look at the pin out here and make sure that I'm oriented correctly. So, where is it? Table of contents. Here we go. This is what I want. Okay, so we have this version. Chip select. Yeah, ground is there. Which means I clip it this way. Maybe my clip is. busted? I was just using it. And let's see, chip select is 1, clock is 6, which I have on yellow. Yellow is channel 12. Let's try it again. I should really record less. That would help. Compare directly with a regular boot. Yeah, I could. Like, yellow doesn't change at all. I mean, I was just messing with it, so. Or it's not sitting correctly, like somebody said. I could do a power cycle as well. That might. Maybe it's in a bad state. Yeah. Let's try one more time and then I'll. No, I don't think so. I was just using it. I should put more in my. Like, that yellow line doesn't change at all. Let's do this. I'm gonna unplug it. Like, it's possible, like, maybe I busted it. Nope. Oh no, I lost it. I saw it go by. Weird. All right, let me look. Looks okay. I have another one here I can try it on too. Flip it to test a different line. Yeah, my ground reference moves then though, which is kind of annoying. I'll try a different board. That's what I'll do. Like, I know that one still didn't have it. Let's just try this other one that I was doing yesterday. It didn't look bent. There are, like, some components right there that makes it a little tough. Well, this is this isn't exciting. Well, that's it working, but see, yeah, yellow is still not. Still don't have a clock. So this is interesting because this is what happens when it initializes okay. So one thing I want to do is, as I'm doing this improvement of Flash, I want to actually, like, see here when the code's running, it's having to go to the Flash every few, like, 20 milliseconds or so. So there's a 16 kilobyte cache, right? And ideally what we would do is we wouldn't have to go outside that cache for, like, regular code. So yeah, let me. I don't know why it must be the. This side looks okay. Maybe no. Weird. Oh, well, now it's running, so we can see that. After I, like, said these clips are awesome, I'll take it even if this clip is not. Weird. Like, yellow is a separate. Well, that's uneventful. Oh, you know what I can do? What? I'll just switch it. Green's doing something. Blue's not doing anything. This is how I can tell. Maybe. So that's blue. Let's see if I... Oh. Weird. Wait, what did I just do? I just switched clock to... Yeah, that looks right. Not very good, though. Huh. Yeah, the Salier might be... Bye, Keith. Yeah, I'm sorry, I'm overtime. All right, let's wrap up. I'll maybe keep poking this. But that's good next step. So I think the next step is to see how far it gets, and we should be able to see like the execution of the... No, should we? I guess we're not running anything external to the flash, but we should see if it tries to start it up. Let me take a time code. Wrap up. Well, thanks again for everyone for hanging out. I'm happy that a bunch of you got the notice that we're on Thursday. Next week we'll be on Friday. I'll be working all week. I'm taking a 3-day weekend this weekend. So thank you all for hanging out. Thanks to ladyada again for dropping by and going into the deep dive of the design of the cutie pie and the itsy bitsy. Keep an eye out. If you have any questions, or wait. Yeah, if you have any questions, go to Discord, which is adafru.it/discord. If you want to try the Cascade Tommel stuff and take a look at the Flash stuff, that would be awesome. But yeah, I'll I'm working towards supporting different Flash chips on the RP2040. So hopefully we'll get a good either a stage 2 that can do a lot of different chips, or we'll be able to switch stage 2s depending on what we're going to use. Gareth says, is adding a new language UK English? I think we already did. I think Weblate has it. I saw that we're building it now. Weblate, CircuitPython, view project languages, English United Kingdom. Yeah, so we have it now. So if you want to contribute CircuitPython in English United Kingdom, check that out. You could do that. Thank you again, everyone. Please support me by supporting Adafruit by going to adafruit.com. Keep an eye out for Feather RP2040s. Join the Discord if you want to see a link go by if they're out. Like I said, we only do the email when we have a lot in stock. Early on, we may not actually send the email. So secret. Yeah, ran out of time for the clock. Yeah. Thank you again, everyone. And I'll talk with you all next week on Friday. And I guess we'll give Spook some pets here too while we're at it. Hey, kitty. think I need to get a lapel mic so you can hear him purr. Anyway, thanks all.